Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we are going to talk about the lesson of continuity of a function or the continuous function. First, we are going to talk about the continuity in general, continuity at a point, and the types of discontinuity or the points of discontinuity. First, let's start the general meaning of continuity. When someone says it is continuous, it means it's going without being stopped, non-stop point. So when you go or walk or move without stopping you, it means you are walking continuously. Now, in math, functions can be classified into two types. Either it's called continuous function or it is discontinuous function. Sometimes we describe it like the water flow. If the water flow is coming like this, continuous, nothing stopped it, so continuous water flow, but the other one drops, it means something stopped it. Also here, when you look at the graph, if we can draw a graph of a function without stopping or without lifting our hand, in this case we say the graph is continuous. But if you stop for a while, or if you lift our hand, it means the graph is not continuous, or because there is a break here. These are some information about continuous function. Now, mathematically, let us take these three examples. First example, pretend there is a pen and you want to move on this line. Clearly, you will move continuously. Nothing will stop you till the end of this line. So this line is continuous. The second one, you move on the curve, but you must stop because you reach the end. So you have to jump to go to the other part of the graph. So there is here jumping discontinuity. The third part is the jumping discontinuity, here at a point. And this point clearly at x equals 1. So at this point, there is a jumping or there is discontinuous. The third one, there is a hole. The graph will stop here, then jump for somewhere, then come again to the graph at x equals 4. So in this case, we can now develop the definition of continuous function. A function is continuous if it has no gap, no break, no holes. And at the same time, as you can see in the first graph, and at the same time, also we can develop a definition of discontinuous function. A function is discontinuous if it has a hole, or if it has a gap, or if it has a jump, or it has a break. So these are the definitions of continuous and discontinuous functions. Let's go back again. This graph is continuous on all values of x, or continuous all real numbers. The second one is continuous also on all real numbers except the point of discontinuity, which is 1. And we call it function is continuous on all real numbers except 1. The third one is continuous on all real numbers except x equals 4. So the second graph, there is jump discontinuity, while the third graph has a point or removable discontinuity. A point or removable discontinuity. Sometimes we call it hole discontinuity. Point or removable discontinuity at x equals 4. Let us talk now about another case when we have a graph and there is infinite asymptote or infinite jump here when the graph goes to infinity from both sides or one side. And this kind of discontinuity is called infinite discontinuity or asymptotic discontinuity, because if we move on one of the curves, we will go either down to minus infinity. We cannot go to the other side of the graph. So this point of discontinuity. Look at this example. We need to study the continuity of a function. That means we need to find the x values at which the function is discontinuous, if any, and also we need to classify the types of discontinuity. Imagine that an object is moving on this graph here. So when I move with no stop till I reach this point. So something will stop me, a hole. That means the graph is continuous everywhere except here, the first point, -1. What kind of discontinuity here? Clearly, it is what? It is hole or point discontinuity. It's a point discontinuity. Now let us continue talking about or moving. So I will move here, but I will reach forever. I will go forever. That means I will never go to the other one unless I stop, then I start from down. That means there's a huge break here. It is at x equals 1. So at x equals 1, at this point, there is an infinite discontinuity, or sometimes we call it asymptotic discontinuity. If we continue walking here on this graph, of course we will stop again at x equals 3. And at x equals 3, the point of discontinuity or the type of discontinuity, we call it jump, because we have two different heights. So this is the example that we solve. Now that means there are 3 or more maybe, but there are 3 discontinuity types: point discontinuity, infinite discontinuity, and jump discontinuity. And sometimes the point discontinuity, we call it removable discontinuity, and the infinite, we call it asymptotic discontinuity, and the jump, we call it break discontinuity or jump discontinuity. Now let us talk about the second idea of the continuity, which is the continuity of a function at a certain point, not in general. It means we have a graph of a function and we need to study why this function is discontinuous at that point, or is it continuous at this point or not. Either if it is whole or jump, what's the problem? What's the idea of being discontinuous? So there are 3 conditions of continuous function. What are these 3 conditions? We will see that there are 3 conditions, but the main one, or the general one, is when a function is continuous when the exact height of a function, if you remember, equals the intended height. If we have a function, so the exact height and the intended height. As you can see here, sometimes this one, the hole here, is the intended height, while the shaded point here is the exact height. Sometimes they are not equal. So in this case, we say not continuous. So, but sometimes this condition, the one condition, is ambiguous for some students. So we break it into 3 conditions. Condition 1, a function is continuous if it is defined, if the exact value of a function defined. So if I want to study the point A, I need to make sure that the function is defined at that point. Then also I want to study the limit. The limit exists at that point. And we don't forget to say that if I want to study the limit, I have to study the left limit and the right limit and the right limit, and they should equal each other. Now, if the result of value of f and the result of the limit are equal, so this is the third condition. So not only defined and not only exists the limit, but the function should be defined and the limit exists and they are equal. So these are the three conditions that we need to check for any point if I want to study the continuity of that point. Solve some examples about discontinuity and conditions of continuous function. Look at this example here. We want to study the function is continuous or not, or why it is discontinuous at x equals 1. We know there is a jump discontinuity, but we need to know what condition is not satisfied here. Which one of these? First, let us check f is defined or not. Clearly, if you remember, f of 1, it means the exact height of the function at x equals 1. So at x equals 1, this is the exact height, not the open circle, the shaded circle. So this is the exact height of the function. And clearly it is 2. So the exact height is 2. That means f of 1, yes, defined. Now, let us study the limit. So here in this case, we need to study the limits from left and right, since we have a break. So we remember the limit from the left or from the right is the intended height, not the exact height. And we can see here the graph is moving towards the height of 5 from the left. And from the right, the graph is moving towards the point, the height of 2. That means we have two different heights, which means the limit from the left is 5, while the limit from the right is 2. Since we have two different heights of the limit, that means the limit does not exist. Unfortunately, the limit does not exist. So, which means the second condition here is not satisfied. So there is a jump discontinuity because the limit does not exist. We can memorize this one as a rule. Always jump discontinuity happens when the limit does not exist with the second condition. So even if I want to check the third condition, no benefit for checking it because the second condition is not. Now also we know there is here a point or removable discontinuity at x equals 4, but also we need to know what condition is satisfied and what condition is not satisfied. We start with f of 4, and everybody knows that f of 4, it means the exact height of the function at x equals 4. So we go to 4 and move up, so we'll meet 2 points, this point and that point, and we usually say the shaded point, the black point is the exact height. That means f is defined and equals what? 3. So the first condition is satisfied. Now let us check the second condition. Also we need to study the left limit and the right limit. And clearly when I move here from somewhere till reaching when I go to 4, that means I'm moving from here to there. So the intended height, not the exact height, it's 1.5 or something like that. Okay. Then when I go from right, so when I walk towards 4 from right, the same height. So I get the same height, which means the limit from the left 1.6 and the limit from the right also 1.6. That means the limit in general when x approaches 1 exists and equals 1.6. That means the second condition also satisfied. But be careful, we need to check here the third condition. Not like the previous example, we didn't check the third condition. Here we need to make sure yes or no, the limit and the exact are equal or not. So this one we got height of 3, but this one we got limit of 1.6. Unfortunately they are not equal. That means the function is discontinuous at this point because the exact height doesn't equal the intended height, or because the limit doesn't equal the exact. So also we can keep in mind that the function has a point or removable discontinuity when the exact doesn't equal the limit. So only the third condition fails here with the point. And don't forget, with jump, the second condition is not satisfied. Now look at this example that here that represent this function. We draw it by this way, but in fact there is a hole here, but it's not shown clearly. So there is a hole here. So we need also to check the three conditions. If I want to find the first condition, if I want to study the first condition, which is the exact height of 2 or at 2. So this is 2. When I go up, I don't meet any shaded or black point, which means clearly the function is not defined at 2. So directly we say the function is discontinuous at 2. No need to check the other conditions. But if I want to check the other conditions, clearly the limit exists and equals 4. But no benefit of studying this. Now, more example. This is a piecewise function, and here I don't have a graph. So I need to check the continuity of this function without seeing the graph. So this is the piecewise function, is defined into two areas or two intervals. So it's similar to write two places or two areas, before 0 and after 0. Before 0 it is 2x to the power 3 plus 1, and after 0, I change the color here, it is minus 3x plus 1. So the domain of minus 3x plus 1 is any number below 0, and the other one any number bigger than or equals to 0. Now we need to study the three conditions. What's the first condition? F of 0. Here I cannot say intended height or exact height. I need to find the exact value and I replace. But where should I replace? Should I replace with the green function or the purple function? Clearly we need to replace with the equality. X equals 0. So we need to replace with 2x to the power 3 plus 1. So when you replace here, we can just replace x by 0. So we get f of 0 is defined because it is 2 by 0 to the power 3 plus 1 and equals 1. That means the exact value of a function is defined. Now let us study the limit. Since it is a piecewise function, so we must study left limit and right limit. How to study the left limit and right limit? Limit to the left of 0, it means we will use the function of minus 3x. That means we need to use the limit of the function minus 3x plus 1, and the limit here when x approaches 0 from the left, just I replace 0, so I get minus 3 by 0 is 0 equals 1. So the limit from the left is 1, and limit from the right also 1, because when I find limit when x goes to 0 from the right, I replace into the function of 2x to the power 3 plus 1, and also I will get what? 1. That means the limit exists and equals 1. So here clearly the f is defined and equals 1, and the exact is 1, and the limit also exists and equals 1, and they are equal. So here the three conditions are satisfied. So yes, the function is continuous at 0. Now let us take the last example, one of the AP calculus questions. Which of the following statements is or are true for the graph of the continuous function shown below? If you remember that when I have a hole and the shaded point with it, clearly this shaded point means the function is defined, and this hole, it means the limit exists. And if you remember, the third condition shouldn't be satisfied. But let me check these answers. First, limit from the right equals limit from the left. Yes, we know that because the intended height from here equals the intended height from there. And limit equals the exact. Unfortunately, no. They are different. The height, the exact height is different than the intended height. So, and F has a removable discontinuity. Yes, it has a removable discontinuity because there is only a hole. So only I and triple I are correct, which is the answer is here D. So this is one of the AP questions. Now let's go to the conclusion. Remember that a continuity at a point is, first condition is to know F is defined. Second condition, limit exists. And third condition, they are equal. And we remember that jump discontinuity always with this condition. The limit usually does not exist. With a point discontinuity, usually either the third one is not satisfied or the first one is not satisfied. Because if I have a shaded point, so yes, the first is satisfied, the second is satisfied, but the third one is not satisfied. And if I don't have the shaded point, the first one is not satisfied. Thank you very much.